Hello, welcome to our channel. In this video, we will talk about interval notation and how we can represent an interval on a number line. So we will basically look at these examples. The first one, we have x greater than 2. So let's first write it on a number line. All right, so this is a number line representing all real numbers. We can place 0 somewhere here. So we are looking at all real numbers greater than 2. So we can have 2 somewhere over here. That means we are looking at all these real numbers. All of these real numbers is strictly greater than 2. So we have a hole at 2 and we look at all these real numbers. So if we draw a circle over here, that means we don't include 2 and we have arrow pointing that way. So this range is x greater than 2. So any x value over here, x can be any number over here. So all these are greater than 2. Now using interval notation, we use parentheses when we don't want to include the endpoint, 2, and we can go up to infinity, and we never include infinity. So to infinity is in the interval notation for x greater than 2. Let's look at x greater than or equal to 2, which is very similar to the first one, but little different. So first I'm going to draw a number line again. So I can place 0 somewhere here and 2 somewhere here. So in this case, we are looking at all these numbers to the right of 2 because all of these are greater than 2. And we can include 2 also. So we can denote this by using a circle filled in. So this solid dot means include the endpoint also. And then we are looking at all the real numbers to the right of 2. So this represents x greater than or equal to 2. And in interval notation, we can write this as this square bracket 2 to infinity. So when you have this square bracket, that means include the endpoint. When you have this parenthesis, that means do not include the endpoint. So in this case, we are looking at all real numbers. In the first case, we are looking at all real numbers strictly greater than 2. We are not including 2. In the second case, we are looking at all real numbers 2. So in the second case, we are looking at all real numbers greater than 2 and 2. So we are including 2. That means we can use this square bracket. So this was second one. Let's look at the third one now. I'm going to do that here. So again, first, let me draw a number line. And we can place 0 anywhere here. And we are looking at all the real numbers less than or equal to 3. So let's say 3 is over here. So we are looking at all the real numbers less than or equal to 3. That means to the left of 3. So we can include 3 because it says less than or equal to. And we are looking at all these real numbers. So this is how we can represent this inequality in the number line. And in interval notation, we start at negative infinity. Negative infinity is at this far left end. Negative infinity. We go all the way up to 3 and we include 3. So we have a square bracket at 3. So this is the interval notation for number 3. Let's look at number 4 next. Okay, first, again, I'm going to draw a number line. We can place 0 somewhere here. So it says x is greater than -1 and less than 2 and including 2. So if you put -1 over here and 2 over here, so you can include everything between -1 and 2, and you can include 2. So it will look like we don't include -1, so we draw a hole on top of -1. We include all these and up to 2. So we include 2 also. So we draw a solid dot over here. So this represents all the real numbers between -1 and 2, including 2. So our x can be anything over here, any real number here. So in the interval notation, we don't include -1. So -1 with this parenthesis, and we go up to 2, and we have a square bracket here because we include 2. Right? So we are done with the fourth one. I'm going to clear all these so that we have space to work on the next 3 problems. So let's look at number 5 next. The first step is to again draw a number line and locate some points of interest. I can place 0 here, I can place 2 over here, and 10 over here. Of course, these are not to scale. So we have 2 inequalities given here. X is greater than or equal to 2. That we can graph quickly. X greater than or equal to 2 includes 2 and goes to the right from 2. So the first inequality includes all the numbers to the right of 2 and including 2. Done with the first one. The second one includes all the real numbers less than 10, but not including 10. So we have open hole above 10 and less than 10. So everything less than 10. So we have these 2 inequalities graphed separately here. And it says x is greater than or equal to 2 and x is less than 10. So that means x must satisfy both of these since these 2 are connected by AND. So any x value here satisfies the second inequality, but does not satisfy the first inequality. Any x value here, any real number here, satisfies the first inequality because it's below this blue line, but it does not satisfy the second inequality. So nothing over here is in the solution, and nothing over here is in the solution. So these can't be x value, and these can't be x value. But if you pick anything between 2 and 10, those are satisfied by both of these inequalities, because any x value here will be below both of these lines, green and blue. So our solution in this case, our interval will be 2 to 10, and we include 2 because we have this solid dot at 2, and we don't include 10. So we put parentheses at 10. So this is the interval notation for number 5. Let's look at the next one now, number 6. Again, the first step is to draw a number line and locate some points of interest. So I can put 0 here, I can put -1 here, and I can put 2 here. So again, we will try to graph these 2 inequalities separately. The first one says x greater than or equal to 2. So it will look like this: x greater than or equal to 2, starting at 2, including 2. So this is the first inequality. Now the second inequality is x less than -1. So we start at -1 and not include -1 because it's strictly less than -1. And then we go to the left because it says less than -1. All these numbers are less than -1. So we have graphed these 2 inequalities separately. Now the possible x values are the real numbers that satisfy both of these inequalities because they are connected by AND. Pick any real number here, x. This real number satisfies only this second inequality. So this is not good. Pick any real number x here. So nothing over here is satisfied by any of the inequalities. So none of the numbers here are good. Pick any real number here. that real number satisfies only the first inequality, not the second one. So nothing here is good. So that means there is no solution here in this case. So solution is empty. There is no x value that satisfies both of these inequalities. All right, so done with number 6. For number 7, we can use the same number line because we have the same inequalities. The only difference is these two inequalities are connected by OR. That means we can have x value satisfying any of those two inequalities. So if your x is here, it satisfies the second one. So this will be good for number 7 when you connect by OR. If your x is here, it satisfies the first one. So that is also good. So this means we can have any real number from negative infinity to negative 1. And then we can have any real number over here from 2 to infinity. And we can include 2 because we have solid dot above 2. And we connect then by union. So union means x can be here in this interval or in that interval. So the solution for number 7 is any real number over here or any real number over here. Right, so we are done with these examples. And this is all I have put together for this video. Thank you for watching. See you in our next video.